All right. Well, good afternoon, everybody. Thank you all so much for joining us today. And on behalf of AUVSI, I'm very happy to welcome you to this afternoon's webinar, From Data Collection to Design, the Power of Drone-Based LiDAR. My name is Shannon Walker. I'm the Director of Programs here at AUVSI and will be your host for today's webinar. Before we get started, we have a couple of housekeeping items that we always like to go over with our attendees. As always, the attendee lines will remain muted throughout the webinar. We are recording today's program. A viewing link will be emailed out to all attendees along with a copy of the slide deck within the next few days. You can view all of our webinars and our webinar recordings on AUVSI's Learning and Engagement platform, AVL. Now, if you're listening to the webinar this afternoon and you need any technical assistance, feel free to send a note to the webinar leader using the chat feature at the bottom of your screen, and they'll be able to get you taken care of. Now, after the presentation, we are definitely going to open up this session for Q&A. So attendees, you are encouraged to submit questions at any time throughout the presentation using that Q&A button at the bottom of your screen. But note that the questions will be saved to be answered towards the end of our presentation today. Another thing I always like to note, the Q&A button is a different one than the chat. So just make sure that you're submitting any content questions using that Q&A button, which can be found along the bottom bar close to the chat button. All right, well, let's go ahead and get started. We are excited to welcome an extremely knowledgeable speaker here with us today, Chris Jackson, the UAS Sales and Training Specialist at Frontier Precision. So I've had a sneak peek of this presentation, and it's bound to be really, really interesting. So enough with me. Chris, I'm going to let you take it over.
Awesome. Thank you for the introduction, Shannon. Hello, everybody. Thank you all for attending today. And I'm going to go ahead and jump right into it here. So just to start, a little bit about Frontier Precision Unmanned. We've been around for 36 plus years, and our business is teaching people how you measure matters. We're trusted by DOTs around the country. We're the largest Pix4D reseller in the world. And we're working with many of the UAS manufacturers to integrate new sensors and workflows, kind of anything under that drone umbrella. We're probably touching it in one way or another. And then additionally, we have our whole geospatial team that represents Trimble and really works with a lot of our surveyors and all of our customers. So what we're going to be talking about today is From Data Collection to Design, the Power of Drone-Based LiDAR. Again, my name is Chris Jackson. I'm the UAS Sales and Training Specialist here at Frontier Precision Unmanned for Oregon and for Idaho. A little bit about me. I went to Indiana State University. I have a bachelor's degree in unmanned systems. Started a small business while I was there, doing mainly stockpile volumes, working with the surveyor that was there in the area. After I graduated, spent 3 years in Colorado as a field technician, primarily doing aerial LiDAR and photogrammetric surveys. Also did some bathymetric LiDAR and some magnetic scanning. Then spent 2 years in Bozeman, Montana with a American UAS manufacturer as their test pilot and to provide feedback from a pilot's point of view for product improvements. And now for the past year and a half, I've been with Frontier Precision, teaching people how you measure matters and helping them incorporate UAS technology into their businesses. So what are we going to learn about today? Kind of 5 sections. We'll go over the evolution of UAS. Why are we doing mass data collection? I'll do a little highlight on kind of our star LiDAR sensor, the Yellow Scan Voyager. A little bit about a success story that I was just recently a part of with one of our new customers who had a really cool project out in Twin Falls, Idaho. And then faster, safer deliverables. So going into it, the evolution of UAS. Why are we seeing so much growth right now and so many people adopting this technology? The first thing that comes to mind, people want to be innovative and they're constantly trying to solve for problems that they currently have. And turns out that aerial LiDAR or aerial applications in general are improving a lot of traditional challenges. As we can see from this picture, especially out west where I'm working, terrain is often a big challenge for people, whether it's getting in there or having vast areas to cover, or even just flying and navigating the terrain and have the challenge of terrain following to make sure that you're getting the quality of data that you want. Limited access, significant time to complete this in traditional ways with boots on the ground. And then we've also seen some really rapid technological advancements too. So the ability to cover these vast areas, people want to be able to cover as much ground as they can in a single day. The more efficient you become, the more profitable you are. And then also with the LiDAR technology, it's become a lot smaller, a lot less expensive, and a lot more readily available. So people are, you don't have to be a rocket scientist anymore to use these sensors. And they're collecting great data. And additionally, on top of that, kind of the advancements we've seen with AI and multi-source data integration, pulling data from different tools and pulling all that together. Some of the automated workflows that we're seeing, it's hard to deny the efficiency gains that we're seeing from the AI and some of these machine learning models. So what else is contributing to this? A lot of it's from federal support for the UAS, the Federal Aviation Administration, some of the things that they're doing, working on Part 108. So as you see here, this is an Skydio X10 with one of their docking systems. That kind of is where the UAS industry is heading, but we're not really able to see the full capability of these systems until we can start operating beyond visual line of sight. That's kind of what they're designed for, is for these remote operations. And Part 108 is contributing to that. It's an extension to Part 107 that FAA is putting out so that pilots can more easily start doing beyond visual line of sight operations. Another thing, a company called AUVSI has been making parachutes, which has enabled operations over people for certain aircraft in certain situations, but a big step for the industry. And then also some of the grants that are coming out, one of them being the SMART grants, Strengthening Mobility and Revolutionizing Transportation, and the DIG Act, the Drone Infrastructure Inspection Grant Act. Two ways that the government is trying to enable people to onboard this technology. And then industry adoption. So a lot of this is, we can all pretty much think of a new use case, nearly every day for a drone, but just to highlight some of the few ways that it's being onboarded. Governments, they're using it a lot for infrastructure, roads, bridges, power lines, railroads, environmental companies looking at the technology for wildlife management, invasive species detection, storm damage assessment and impact analysis. And then construction companies doing reality capture, digital twinning is becoming huge, progress monitoring, safety audits, and having archivable site condition surveys. So just a few of the ways that the UAS technology is getting adopted. And why is it important to be an early adopter? The biggest thing is you're going to gain competitive advantages. When this first started, it was all very hardware based. Just having a drone and kind of onboarding that, something like a Phantom 4 Pro is what a lot of people started with. We're kind of in a transition phase where we're going from hardware to more of a software and AI basis of kind of where people are leading and adopting now. And really, if, to put it bluntly, if you're sitting on the sidelines and you're not looking at this technology, your competitors are bringing this on currently and are likely to outpace you if you're not starting to look at how AI and how these tools can benefit you. So a lot of people, the Phantom 4 Pro from DJI, I'm sure a lot of you are familiar with that, was kind of the original workhorse that a lot of people started to deploy out into the field. Now we're seeing expansion and growth to NDA platforms, heavy lift or long endurance systems, and companies starting to utilize the AI and machine learning making them more efficient, providing more accurate products, and improving the client satisfaction, which is giving you a competitive advantage. Cool fact there, recent studies showed that projected growth of 57.5% compound annual growth rate from 21 to 28. I do believe we are on track with that, but it's growing very fast, and we're still just at the very brink of really seeing all the potential that UAS and LiDAR sensor, LiDAR technology can provide for us. So next, why are we doing mass data collection? Why this matters? The biggest thing is unlocking scale and accuracy. In a single flight line, we're collecting millions of points to where we're able to collect, 1,000 acres in hours, not just days or weeks, depending on, your site condition, the location, and also probably less crew that's needed to acquire a lot of this data. The next big thing is having repeatability. Repeatability is huge. So no matter who the pilot is, having the ability to perform the exact same mission on whatever schedule you would like is a really great way to ensure that you're, getting the data that you need every single time. And no matter who's collecting it, it's getting collected the same way. And then on top of that, you're capturing, when you're utilizing the aerial LiDAR platforms, we're often capturing a lot more data than what our current scope of work is requesting. So say we're going out and we're mapping a, kind of residential area, whatever it may be, and you just need to provide a surface for your customer. Well, if their scope of work changes or a new need comes up, you don't have to redeploy because you already have all this other data on the infrastructure that's out there for roads, trees, power lines, whatever it may be. So you're capturing more than what you immediately need, which can save you in the long run, or just being able to reference it again has a whole lot of value. So next, mass data collection is enabling better context for designers and engineering. Providing a 3D context is a huge step from what we were just doing, not too long ago, where all we had were flat 2D plans looking at blueprints. Having 3D context enables you to really provide a new perspective, and really it helps create more accountability for contractors and project managers to meet their timelines and stay within budget, because we have, a virtual reality where we can compare from week to week to week, and just extremely helpful in many ways. Also leads to fewer change orders. So, having 3D data, if something was put in the wrong spot or something's not done in time, whatever it may be, we're able to identify and resolve a lot of these issues more rapidly. It also helps you plan faster because you have more awareness of your site. So rather than looking at a 2D plan or blueprints that can be challenging to kind of figure out how far things are supposed to be away from each other, the 3D view really expands the perspective and the way that you can efficiently plan for a lot of these projects. And most importantly, you're making data-driven decisions. So you're working from measurable, consistent visual reality, not just a piece of paper plan. Next, mentioned a little earlier, multi-source data integration. So the drone is not going to be the tool for every single job that you have. All the different equipment that we offer, it all has its place. But the important thing is, some projects might require multiple pieces. It wasn't so easy just a few years ago to get all of that into a single project. Whereas now, with kind of the help of AI and some of our automated workflows and the power of Trimble Business Center, it's much easier to go out and fly a site with aerial LiDAR and photogrammetry, and then do a mobile scan, as well as a terrestrial scanner, and then walking around with your rover, shooting GCPs. We can add all of that data from all those different pieces of equipment into a single project to make the most rich products possible. So definitely a huge step for us there. Next, going into kind of the star of Yellowscan's lineup, going to talk about the Yellowscan Voyager. So little information on it here. Designed for UAV, light manned aircraft, or helicopter operations. This is kind of the top of the line sensor that Yellowscan offers. And it was designed for high density, high accuracy data collection. It's using the Regal Vux 120 scanner with an IMU, the Aplanix AP30 or 50 IMU. And it's really ideal for these large scale mappings. And we'll see a little more on this next slide why. So some of the key performance highlights here. The Voyager is capable of sending out 2.4 million shots per second with 32 echoes per shot. So if anybody here isn't super familiar with LiDAR right now, basically a laser pulse comes down and those echoes basically determines how well you can penetrate through vegetation. So if a system only has 3 echo returns, you can if you're flying over a forest, you can hit a leaf, hit a branch, and that's all the data that you can send back to the ground. So you're not getting anything on the actual ground. Having 32 echoes allows that laser beam to a lot more opportunity to hit vegetation, branches, trunk, make it to the ground to actually give you your ground point. So in those highly vegetated areas, the number of echo returns that you have has a big impact on how well are you going to actually get data on the ground. It has a field of view of 100-degree swath. So as we're flying, the swath of the laser is coming out perpendicular to the direction of your flight. If we're flying at 120 meters or about 400 feet above ground level, we're covering almost a football field and a half of ground at a time. About 140 meters is what we're collecting in a single flight line. And while doing that, even at that altitude, we're maintaining a density of 525 points per meter squared, while also maintaining accuracy of 1 centimeter and a precision of 0.5 centimeter. So very, very impressive on what it's able to do, especially at the altitudes and speeds that it's able to do it at. So any LiDAR sensor on the market, we carry Yellowscans. Any LiDAR sensor on the market is going to have their own proprietary software that you use to actually generate your point cloud. Yellowscans is called Cloud Station. So they have a few different tiers, but just to kind of walk you through what you do after you get back from the field and you want to see your data. So kind of the first things that we're doing is doing a trajectory correction. That's basically eliminating any errors that might have come from the satellite informations where it's most accurately representing where it was in space while it was flying, and also giving georeference to your points. We're actually doing the data extraction, so generating our point cloud, performing strip adjustments. So a lot of times if you're doing multiple flight lines, there can be some variance on how your points line up. And we want to have the flatter plane that we can have, the more accurate your data is. If there's thickness in your point cloud, that likely means that it's just air tolerance is there. So the thinner your point cloud can be, the more accurate it is. And that's kind of a tool that just helps correct any of those variances. Additionally, we can do classification. So removing any of the above ground features, trees, buildings, cars, all that stuff, and separating that from just your ground points. We're able to colorize our point clouds, which is really great for adding just reference to the sites. If you're not used to looking at LiDAR data, it can be a little disorienting or challenging just looking at millions of points on a screen. So having it in color makes it more interpretable. And that can come from a camera module that you attach to the sensor itself or from a separate flight, separate aircraft, multiple ways that we can do that there. Denoising, cleaning up our point clouds. The cut overlap tool is really nice feature to have, especially for LiDAR data it can get dense pretty quick. You know, if you're out in the field for an entire 8 hours collecting, you can easily be taking 100 gigabytes or more back with you to the office. Obviously, we want to work with as small of data sizes as possible, make it easier on our machines. This tool is just really nice for, when we're flying, we usually have about a 30 to 50% overlap between our flight lines. This tool basically removes any of those duplicate points, leaving any unique ones, but just helps you manage those data sizes a little bit and kind of removes the stuff that you don't need. We can also create ortho photos. So whether it's from a different drone or connected to that sensor, we can create an ortho, producing our different models, so a digital surface model or a terrain model, and then exporting that. Most people are going to be having an N or multiple additional softwares to create the data products that they want. So CloudStation is kind of it can do some things for you, but for a lot of the deliverables, you'll be plugging into another software afterwards. But that's what CloudStation can do for you. So going on to our success story here. Really cool project that I got to be a part of about a month and a half ago or so out in Twin Falls. So little customer highlights here. His name is Declan Ruffing, started a company called Semblance Design Solutions. And his company overview: engineering and architectural design support with leading innovation and LiDAR scanning processing services. So how did we all start working together? As Declan was looking at starting this company, he reached out to Frontier Precision, as we are known as kind of the leader in the geospatial world, received consultation from our geospatial team to make sure that he was looking into the right equipment and software that was going to help him achieve his goals. He bought a variety of equipment: a Basin rover, a Trimble X7 terrestrial scanner, and Trimble Business Center software, and then also received training from the geospatial team on those workflows, as well as getting prepared for what he was hoping to do with the aerial LiDAR, and that's getting training on setting GCPs. So something I like to mention to people, anything aerial is an awesome tool, but it's really hard to prove any aerial data if you don't have points on the ground. So, no matter what the system, we always recommend having ground control points of some kind so that you are able to quality check the data that the aerial system produced. So he got all that training. This project that he's been working on with the city of Twin Falls for designing a gondola that's going across the Snake River Canyon, he decided that this might be a better job for an aerial system to do. So I went out there, I worked with him on a pilot project. I took out the FreeFly Alta X and the Yellowscan Voyager, and had great success out in the field with him. The biggest thing was, or I guess biggest pro of this whole thing was, we went out, we collected accurate and timely data, and it was so rich and kind of unexpected from his customers that it provided a new perspective, and it expanded the scope of work for his project to where now there's multiple designs that are happening in just ways that they can grow the city of Twin Falls. So next we have just kind of an overview of the project here. Pictured above is the area of interest that we were flying. It encompassed a 4-mile span, about 1,500 acres. And we covered all of this with 17 different takeoff locations, 17 flights. We finished everything up in less than 2 days, including setting ground control points. So overview on the project. Why were we out there? To do a preliminary site analysis for the gondola system design. Our objective was to capture accurate terrain and elevation data for feasibility and for his design work. The environment's out there, rugged canyon walls with difficult to navigate terrain. I know looking at that picture, it looks fairly flat on the north and south side. South side was much easier to navigate. Trust me when I say that north side of the canyon was very difficult to navigate, much rockier and hillier than what I was able to tell from the Google Earth image. So your sites are always changing. Don't always expect for your site to look like what you think it's going to based on a satellite image. But most importantly, why this mattered, why was it a good idea to bring in the aerial system? It is a perfect scenario to show that some jobs are just unsafe to do with traditional means, and very time consuming. I don't think any one of us would be wanting to navigate on the edge of a 1,000-foot cliff. So this isn't Declan's design. This is just an AI image that was generated, but gives you a really good idea of how the 3D context really opens up a new perspective and just makes it a lot easier to really envision what your goal is. So yeah, wasn't able to share that, but kind of walking through his process of working with this customer. Starting with phase one of the project was to go out and create a digital twin for the conceptual design. The gondola is going to be about 2 miles long, stretching through that canyon. Just wouldn't have been possible to do without that drone, or at least in a timely manner if he did decide to do that terrestrially. The 3D data made it easier to come up with a plan to achieve a common goal and improve communication between the multiple parties involved, the states and the city, as well as the multiple contractors that are going to be involved in this. And because the data was so rich, it sparked some new ideas for other things that the city can do. So now, after he's presented this to the city, now they're looking at building a new hotel, new parking lots, a new amphitheater that could host 10 to 15,000 people. That's going to be planning to be hanging off the side of this cliff. It's where you can see the different falls there. Next, he's able to use that same data for all these other things that have followed. So rather than having to redeploy to go capture areas, he already has all this data that he needs to do the design for the parking lots, some mock-up designs for hotels, and just really making his job easier, and opened up a ton more work for him. And then one of the really cool things that he's doing is that now that he has a source for 3D data, that's opening up the possibility for him to present these products with an augmented or virtual reality. So one of the things that he'll be doing after he's done with the design is basically creating an augmented reality where you'll be able to ride the gondola before it's even functioning or even built. So really transitioning from a 2D world to a 3D digital world. And this is just a great use case to show how that aerial LiDAR made him more efficient and opened up more possibilities for him. Next, onto our faster, safer deliverables. So this is just some data product examples that are common with this sort of work. So just running through them here, this is kind of focused for what designers, planners, architects, land developers might be looking for. A lot of times they're looking for digital terrain models, so just cleaned bare earth surfaces so they can do planning, looking at grading, providing contour maps, commonly at 0.5 foot, 1 foot, or 2 foot. Great way to look at the slope of the land and really just have a better way to visualize the elevation changes that are happening on your site. And then orthomosaics, kind of your satellite image or your bird's eye view that's collected with a series of overlapping photos. Like I said earlier, you can't always trust what you see from Google Earth. So having an orthomosaic really represents what your scene actually looked like when you were out there working on it. Some more things that are important for the designers, the colorized point clouds. So, adding the kind of perspective and more situational awareness to those points rather than just looking at millions of points. Much easier to see what we're looking at here. And very useful for their initial design meetings as they're planning out everything. Planimetrics, so basically vectorizing everything that you see in an image. So being able to digitally define where all of your parking strips are, your manholes, paint striping, power lines, all that sort of stuff. We're able to get into our software with georeference in a digital form. And then hill shade and relief maps, another way that we can visualize some elevation changes. Really great for, if you're going to be putting solar panels on a building, figuring out which area of the building is going to get the most sunlight, just as an example. So kind of geared towards engineers now, civil, utility, structural, environmental. Tin surfaces are a very popular thing, really commonly used for machine control files. Also plays very nicely with CAD or civil design software. The DSM and DTM, that's what's pictured there below. So just different ways that you can view your scene. If you want everything that was collected, you would be looking at a digital surface model. If you're just wanting to see the bare ground, you'd be looking at a digital terrain model. So different ways that you can use them for whatever you're trying to accomplish. And then cross-sectionals and longitudinal profiles, great for kind of a more focused area. Good example would be power lines. So if you're doing a power line survey and you collected 200 feet from each side, of the right of way, you can focus that down to really focus on what you're trying to see. Some more for engineers, feature extraction. So being able to identify where is all of our trees, all of our utility poles, all of our power lines, cars, noise, low-lying vegetation. We're able to identify all of that and export that out as its own class, if you wish. Slope analysis maps. So any earthwork that you're doing, making sure that you're grading things appropriately. Volumetric calculations, great for estimating and material planning. And for construction, so contractors, project managers, owners, surveyors, some of the things that they're looking for commonly are as-built point cloud. So before something gets built, a pre-build survey is performed. You also want to do that after whatever is built, and you want to be able to compare how close those things line up. Change detection maps can also be kind of used as an as-built too, to see what's changed from one point in time to another. Same thing with progress orthomosaics, and then cut and fill analysis. Again, if you're doing any earthwork, shows you where your low points are, where you need to put material or where you need to take material out to get a flat surface. One more here, some volumetric reports. Again, for stockpile monitoring, excavation, validation, clearance measurements. If you're building a road and power lines, you definitely want to make sure that those power lines are high enough to where a semi doesn't run into them. 3D surface models, so some of those tin files used for machine control, and visual deliverables, kind of like what Declan is doing with his augmented reality, creating fly-through animations and a fairly new way that you can present products to your customers. So with that, that's what I have for you guys. Happy to answer any questions you have. Thank you all very much for attending, and I hope this was of value to you guys. So more than happy to answer any questions that you guys have.
Great. Well, thanks, Chris. We definitely have a few questions rolling in already, so we'll get to that in just a second. But as a reminder, attendees, if you have a question that you'd like to submit, please click the Q&A button at the bottom of the screen, type your question, submit it, and we'll get it into the queue. All right. So I will go ahead and get started with the first question that we have. You've talked obviously a lot about all the data that's collected and the data acquisition. What kind of challenges do you run into during data acquisition?
Well, with me being out west, terrain and maintaining visual line of sight is probably my most common challenge that I run into. I'd say more than 80% of the jobs I've done over the past year and a half have all been in really mountainous areas. So one of the biggest challenges is just maintaining that line of sight. Ideally, the fewer takeoff positions that you can have, the more efficient you're going to be because it's less packing up and resetting up. You can't always trust that satellite image when I'm doing my planning on Google Earth. The scene can look really different from there. So a lot of the times it's just having to do many edits out in the field to account for what's actually out in that environment. And maintaining the visual line of sight when the hills are constantly changing means that I'm very likely to be packing up and moving more so that I can maintain operating within Part 107 regulations.
That makes sense. Yes, the terrain can certainly pose a big challenge. Thank you for that. The next question that we have asks, does the use of LiDAR require a restricted flight envelope? For example, maximum airspeed, maximum or minimum flight altitude, ideal flight endurance time, that type of thing.
So it's going to be highly dependent on the sensor that you're using. The sensor that I talked about, the Voyager, is kind of the top of the line. So it's using a more powerful scanner where it gives you more range. So with that sensor and the higher quality IMU, we're able to fly higher and fly faster. With some of the lower end sensors, you might be capped at, 80 meters above is their recommended flight height for best data acquisition. With another sensor, since the Voyager, it can go on manned aircraft too. For my rules, I have to stay within 400 feet of the ground. Obviously, helicopters, manned aircraft can go higher than that. So you have to have a strong enough sensor to be able to achieve those points from that altitude. Same thing with speed. Ideal flight endurance time is really just going to be dependent. Are you powering that sensor from an internal battery, or are you powering that from your aircraft? If you have a long endurance aircraft, we offer the Skyfront Perimeter 8, for example, set a world record for 13-hour flight time. If you're powering that sensor from that aircraft, you can push how long you can fly it, but you also have to consider the size of data that you're able to store on your SD card. Eventually that's going to fill up. So kind of finding a balance there.
Perfect. Thank you. All right. So let's keep moving because they are rolling in now. So is LiDAR usually combined with other sensors? And if so, what are those?
Yeah, it can be. I would say probably the most common integration, if you're doing it simultaneously, is going to be a camera for either colorizing your point cloud or generating orthomosaic. However, when you do combine that, if you're wanting to collect two types of data at the same time, say we're doing LiDAR and photogrammetry, we have to prioritize our flight for photogrammetry because the frame of view is going to be different between what your camera sees and what your LiDAR swath is going to cover across the ground. So if we're wanting to create an orthomosaic, say from the camera module that's on the Voyager, we have to plan our flights for spacing that represents our photogrammetric product that we want to produce. And then thankfully we have the tool in Cloud Station where we can cut out all those duplicate points because we're going to have a much higher overlap for the LiDAR than what we typically would need.
Got it. Thank you so much. Okay, so question came in while you were sharing the case study for the gondola customer. And that asks, for that customer, what was the deliverable in terms of, was it a raw LAS? Was it raster? Was it DSM?
Yeah, so what I produced for Declan was the full point cloud, so a DTM and a DSM that was geo-referenced to his control points. So that's what I provided for him during our pilot project. Now he's taken that data and has run with it for all of his design and BIM modeling and all the other use cases that he's finding from that data set.
So interesting. Great. Thank you so much. Okay, next question asks, do you provide a drone in the box solution for advanced customers? For example, one-click deploy, LiDAR collection and return and download? Or do you only offer like a hands-on LiDAR collection?
So right now, I guess for being a drone in the box solution, what comes to mind for me is like our docking systems. We don't currently have a dock right now to where we can just deploy it and go collect LiDAR. They're more tailored for some of the smaller drones right now. I think we are getting there. We're working with a new dock manufacturer that has the ability to carry some bigger drones, still figuring out if we'd be able to get something with LiDAR on there. So I don't think we're too far off from that. But right now, it's definitely more of a hands-on collection where we're going on site, setting up the aircraft and the sensor, flying it. A lot of it is automated though, so additionally, most of my time is not me actually flying. It's me flying the flight plan and watching the drone do its thing. So it is somewhat hands-off right now, but in the future, will definitely become more of that one-click deploy automated workflow.
Perfect. Thank you. Mm-hmm. All right. So this next question is sort of asking about maybe a different use case opportunity, or maybe it's been done, but it asks, have you ever exercised these capabilities to support archaeological surveys, like prior to land development, looking for historic structure footprints, historic roadbeds or trails, lost or unmarked cemeteries, kind of defining the extent of cemeteries, things like that? Have you used it in that sense?
Yeah, 100%. Actually, my first company that I worked for in Colorado, called Juniper Unmanned, they've been featured on a number of shows on the History and Travel Channel, where they've gone out and used aerial LiDAR technology to look for some of the lost ancient ruins. And kind of personally for me, the coolest project that I've ever been on, I had the opportunity to go out to Skinwalker Ranch, which is a show on the History Channel, where we're kind of doing a similar thing, looking for features on the ground that they weren't sure where they were from, whether it was from old tribes that had been out there, Indian reservations. But yes, that is a very common use case, and the ability to remove the vegetation, and look at the ground is how you make those features pop, what you're looking for. One of the things we were looking for was a triangular feature that they think was an old Indian fire pit. Wouldn't have been able to see that if there was vegetation over that. So really cool use case. Love to be on more of those.
Yeah, that's fascinating. Thank you for sharing that. So I'm looking at our questions, and there's sort of a shift in direction to ask, a crystal ball perhaps type of a question. Nobody has it, but in your opinion, do you see a projected timeline for the implementation of Part 108?
It's hard for me to, I don't want to give like a date or a month, because that's pretty challenging, especially with some of the changes in the administration and kind of the government downsizing. It's really hard for me to say when that's going to happen. I know it is on the roadmap and something that they're currently working on. I'd like to say, within a year would be awesome. But it's all kind of hearsay right now. And yeah, hard to say.
No, I feel like we get that question a lot in these webinars, and I love to hear varying opinions of what people think. So appreciate that. All right. So in the next question, is another crystal ball. You probably can't predict the future, but given the recent political sensitivities surrounding, drone acquisitions from global partners, what are your thoughts, or what are you seeing on maybe the potential impact on the U.S. industry and the drone supply?
Yeah, that's a great question. Definitely dealing with that on a daily basis. The biggest thing is a lot of this is surrounding DJI right now. That's really many people's favorite drone, this drone that they started with, and kind of the ones that are setting the bar for every other manufacturer out there. My personal opinion, I don't want to see DJI go, but also at the same time, I think it's kind of the kick in the butts that a lot of the American manufacturers need. It's opening up opportunity for them to really start making the products better and really competing with DJI. And they're also just kind of a different platform in general. Like the aircraft that I flew for Declan's project, that FreeFly Alta X, has a higher payload capacity than what anything DJI offers. So as you start getting into some of these more advanced operations, there's a lot of other aircraft out there that start making sense for people. to where DJI might not be, the biggest issue for you to worry about. For DJI, we are having challenges getting their products in. We've seen their products getting stopped at customs, getting sent back to China. So, this is really kind of sparking, the initiative for people to kind of make that transition over from DJI to American-made products, kind of future-proofing their programs. Again, it's all kind of hearsay what the final outcome is going to be. I don't foresee like a grounding of their aircraft, but there might come a point where we're not able to get new DJI aircraft in. I really feel the best things that people can do, use the equipment that you have. DJI is awesome. I love it, but it's becoming harder to use depending on the type of customers that you're working with. And then just with kind of the uncertainty of the future, it's pushing our American side further, which I think is a good thing.
Awesome. Yeah, thank you. I appreciate that. All right, so we kind of went into the more philosophical future prediction, but let's bring it back to the presentation itself. You talked about the echo imprints. Can you talk a little bit more about why the number of echoes are important for LiDAR scanners?
Yeah. So out here, we work in a lot of forest environments with forest type customers. A lot of times they're looking for, how close are all of our trees together? What's, how dense it is in there? There was a recent project where a landslide had happened. To get some of that sort of information for the landslide in a dense vegetated area, using some of the more entry level LiDAR systems can make it challenging to get the data that you actually need. The biggest value of how many echo returns that your sensor gives basically directly equates to how well am I going to be able to see the ground. So, if you're working in more of a urban environment that has a lot of roads and hard surfaces, those lower end sensors are great. You get all the things you need. But when you're in really dense vegetation and you're trying to get points on the ground, having 32 opportunities to hit a leaf and a branch and a leaf and a branch and a trunk, you need that sort of capability to get the data that you want, depending what you're trying to do.
Absolutely. Yeah, that was really, really interesting. Thank you. Okay, so you talked about the Voyager. Can you share how much ground you can cover in just a single day with the Voyager?
Yeah, I think I mentioned that earlier. So in a single flight line, we're covering about 140 meters of ground at a time. So about almost a football field and a half. In a single day with, kind of ideal conditions and minimum takeoff areas, being able to fly at 400 feet or just under 400 feet, so you're not busting that cap, and being able to fly at 10 meters a second, you can really cover some ground. And I would say covering 2,000 acres in a day isn't out of the question if you have, some good healthy batteries where you're getting long flight times and kind of an ideal site situation where you're not having to pack up and move to maintain line of sight. I think 2,000 acres is pretty easily achievable with that sensor.
Awesome. Great. I'm looking. We have a couple of questions left. So attendees, if you have any that you'd like to get in before the end, make sure you're submitting them. The next question is about, Frontier Precision. Where are you guys present? So are you guys at SOF Week or any other upcoming shows?
We are at a number of shows. The slide that I have up right now kind of shows all of our offices, and we do have personnel. We're working on having an office in every state eventually. Our unmanned side, we're expanding east very rapidly. So if there is something that's related to UAS, it's very likely that we're going to be there. I can't speak for all my team members on which shows that we're going to be at, but if there is a UAS presence in it, and it's geospatially or high accuracy survey related, very high chance you will see us there.
All right, great. Well, on our end, we hope to see you at Exponential in a couple
We,
weeks.
we will be at Exponential. I personally won't be at this one. All those big shows we're definitely going to be at, and also do a lot of the smaller kind of more trade specific shows as well.
Amazing. Great. Okay, so a few more questions coming in, going back to the echoes, building off of the echo question earlier. Is it possible to fly a series of crosshatch patterns with maybe a lower cost LiDAR and achieve a greater number of echoes that way?
Definitely. So you're not really getting more echoes that way, but the more angles that you can introduce, because if we're flying forward, the swath of the LiDAR sensor is going to come out perpendicular to the flight. So if you're flying over a forest, we only have so many opportunities that we can bounce through the vegetation to hit the ground. So flipping that sideways and doing a crosshatch pattern allows that laser more opportunities to find spaces where it can get through to the ground, where you can definitely improve your density that way.
Perfect. Thank you. And then, obviously LiDAR can do a lot, but acknowledging, some of the current limitations of LiDAR, have you found any specific use cases for aerial GPR?
I haven't personally used aerial GPR. I know it seems like it's had a kind of a quicker grasp in Europe than it has in the United States for whatever reason. If it's FCC regulations, I'm not super sure. I know that there are systems out there. We actually represent the manufacturer, SPH Engineering. They have a GPR system that's able to go on unmanned systems. I think pretty commonly being used for like UXO, unexploded ordnance detection, variety of other things. It could be, finding buried items, clandestine graves. There's a number of use cases for it, but from what I've seen anyways, I haven't seen it really pick up in the States yet. It seems like it's really picked up in Europe though.
Interesting note. Thank you.
Mm-hmm.
Okay, so I think we're about near the end of our questions that we've gone through. So I'm going to end with a who do we contact question. But who can somebody contact to present new drone aircraft for LiDAR use?
Like specifically through Frontier?
Let's go through Frontier. Yes.
Yeah. So any one of our offices, you can call any one of our offices, whichever one is closest to you is who I would recommend you reach out to. A lot of our geospatial guys have knowledge on the UAS, and if they don't have a UAS guy in that office, they will hook you up with the closest one to you to be able to help you out. So whichever office is closest to you, reach out to them and we will get you taken care of.
We can see them all on the slide right now with context. So that's a very relevant tip to give. Perfect. All right. Well, it looks like we have made it through our questions with only a couple minutes left remaining. So before we close out, Chris, any closing thoughts, closing comments that you'd like to provide?
Just thank you all very much for attending. I hope you got some value out of this presentation. I'm out of our Bend, Oregon office, which is listed there. So if you have any questions directly from me, feel free to contact my office. Just thank you all very much for attending.
Well, I will echo those thanks and say on behalf of AUVSI, thank you, Chris, for this great presentation. Lots of positive feedback in the comments about how great it truly was. So, and I'd also like to thank, obviously, Frontier Precision for their generous sponsorship of today's webinar. So attendees, I did note this at the beginning, but you will get a link to access today's recording within the next few days. Within that page, you'll also have a download link for today's slides as well. So all of our webinars, upcoming and past recorded, are available on AUVSI's learning and engagement platform, AVOL. And if you have any questions or comments for our team, please feel free to reach out to us at education@auvsi.org. So lastly, today's program is copyrighted by AUVSI with all rights reserved. Thank you all so much for being with us this afternoon. Thank you, Chris, for this great presentation. We really appreciate it, and we hope everybody has a wonderful rest of their day.
Sweet. Thank you all very much. Have a good one.